this video we will discuss about stimulation of tongue innervating neuron can activate cervical lymph node neuron. So basically they want to show that stimulation of neuron at one side can activate the neuron on other side or at other organ. So first they check their system whether they are specifically able to transduce their reporter in a specific part of neuron or not. So for that they use this hSyn EGFP reporter using AAV vector, that is Adeno associated virus to retrovirus vectors, and after 42 days they are able to see these EGFP signals, and also they are able to see the CGRP signals which is occurred because of the process, because it is occurs in this trigeminal ganglia. This hSyn reporter is usually expressed in this trigeminal ganglia, and there also they are able to see this CGRP. So this CGRP signal shows the specificities of this EGFP expressions. So once validating their specificities of their transduction system, they are now wanting to check whether they can stimulate by stimulating in the neuron at one side, that is at the tongue, whether they can activate the cervical lymph node neuron or not. For that, what they did is they inject this optically stimulated system or optically stimulated reporters in this tongue at the tongue site, which is stimulated by this 473 nanometers, and the actual outcome that they measured is the blood flow, and the blood flow that they have measured using the 70 nanometer laser speckles. The higher the blood flow, higher the intensities they are able to see. So in the wild type, they are able to see baseline blood flow in the cervical, and that this is the reference region. So basically they measure the difference in this reference region and this blood flow intensity. And in the case of their this CatCh-EYFP, which is transduced at the tongue site, so what it does is when in the presence of light, it will increase the calcium influx, and that will leads to the high neuron firing, and they expect to see this neuron firing will activate the blood flow in the or increase the blood flow in the cervical lymph node. So in the presence of this tongue that is transduced with Scn10a CatCh-EYFP, they are able to see increase in the intensity of the blood flow in the cervical lymph node. And in the presence of the negative control, where they used BP vaccine, which actually inhibits the NA, and without NA channel, the neuron would not be able to fire or activate. So they should not have seen. They will not see any blood flow or reduced blood flow in the cervical lymph node. And here they see minimum signals even lower than the, looks like it's even lower than the signals from the wild type, but when we check the quantification, it shows that it is close to the wild type. And in the case of this CatCh-EYFP plus vehicle, they are able to see increased delta LN perfusion, increased intensity of this blood flow. Thereafter they use their system to check it. They use their approach to check a different system, where what it is, they took this same Scn10a CatCh-EYFP into the tongue, and at the same time it will what it is, at the site of cervical neuron they inject this TRVP M cherry. Here we can see the TRVP M cherry neuron in the case of wild type. The transductions is there, and what will happen in the presence of light, this Scn CatCh-EYFP will trigger this FOS inductions, and FOS inductions is EGFP labeled, So whenever FOS inductions occurs in the presence of light, they are able to see EGFP signals. So in the wild type there is a baseline signals, and in the case of control, so in the wild type here they do not use the tongue with this Scn10a CatCh-EYFP. In the case where they transduce the tongue with Scn10a CatCh-EYFP, they are able to see enhanced FOS inductions that can be seen their high inflorescence. However, when they transduce this cervical lymph node with this HM4D, its basically job is to prevent the neuron firing. So what will happen since it will inactivate the label neuron or this M-cherry label neuron. So because of that they are able to see reduced M-cherry label neuron, and because of the reduced M-cherry label neuron and the reduced neuron firings, they are not able to see FOS inductions. And these things they have quantified on the right hand side, where we can see that in the presence of this CatCh-EYFP and in the absence of HM4D, they are able to see enhanced FOS activations. But in the case of control and in the presence of HM4DG at the cervical neuron side, they are able to see reduced FOS signals, similar to the comparable to the wild type. This indicates the specificities and the ability where the stimulation of tongue innervating neuron can activate the cervical lymph node, or in general the stimulation of one neuron can activate the other side's neuron. This is how they validate their hypothesis, and by using the two different systems. And I hope you are able to understood their experiments. If you need to understand more about their results in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.